Once again, welcome to the YouTube channel Unknown Warrior. And today we are going to discuss very interesting topic, that is embedded systems. So in this whole video, we are going to focus on what do we mean by embedded systems, then where are they applied, then we are going to see the simulation and implementation of few embedded systems and many more. So without wasting much time, let's begin. So first of all, we are going to see what is embedded system. So basically, this system is the combination of software as well as hardware, and it is designed for the specific functionality or purpose. So it can be programmable or it can be of fixed functionality. So this is nothing but embedded system. That is, it is designed for the specific purpose and they can be either programmable or they can be of fixed functionality. Next, there are various applications around us which are designed or which are prototyped by using embedded systems. So which are these embedded systems? So few of the examples I have shown on the screen. So like industrial robots, GPS receivers, digital cameras, DVD players, MP3 players, microwave ovens, photocopiers, gaming consoles, set-top boxes, wireless router, and many more. So all these applications, as you see, are doing some specific function, right? Industrial robots, as you can see on this picture, they are specially designed for picking up some product and landing it on some uh, platform or some roller, right? Whereas digital cameras, they are specifically designed for capturing the images and storing at the cloud or some other platforms. Then DVD players, simply playing videos and movies all around. Then MP3 players for listening to music. Micro ovens, cooking delicious food. And photocopiers, then gaming consoles, the favorite one of all the children around the world to play the games. Then set-top boxes for viewing the television or the channels, your favorite channels. Wireless router for high speed internet facility. And there are many applications around us like refrigerator, that for cooling up the food and preserving it. Then we have embedded system like fan for an AC. So these are all the applications that are nothing but embedded systems. So as you can see, they are specifically designed for some specific or fixed function. So all these devices are can I can say having the fixed functionality, that is they are not programmed, or there are some IoT devices nowadays. IoT domain is now a very famous domain around the world, which is connecting many cities wirelessly, that is through internet. So this is the trending technology, that is IoT, Internet of Things. So this is also using this embedded system technique or domain. So this is high tech domain, IoT. So we are going to see from basic circuit to all the IoT applications, how to connect all these devices through wireless or through internet and all. So we are today going to focus on the simulation of the system and actual implementation of the system. So basically you will ask the question like why it is necessary to simulate the embedded systems. So the major purpose is that if you directly design some your ideas on the paper and then you directly purchase some hardware that you require for your embedded system and you directly go and just put some wires, and you all must be familiar with the voltages, currents and many more. So if there are some fluctuations in those currents, then your circuit or your hardware that you are using may get what we can say short. So if they get short, then those hardware are unable to be used in your embedded system, and you need to again go and purchase, or you need to find some other we can say hardware replacing the one which have got short, and this will lead to your software, or we can say the embedded system you are using to a high cost, and you can just get a poor, we can say, cost, or poor product uh, purchasing cost, and that should not happen actually. So what we do is, we can do the simulation of the embedded system which we are designing or which we want implementing. And then after the simulation, and then we found that yes, by using these all hardwares, and by doing these all connections, and after running those simulation, our whole embedded system is running well. Then we can actually start with the implementation by taking actual real hardware and then connecting them according to the simulation that we done. And then you can, without wasting the hardware cost, and without wasting or putting much time in those, after if some short or some errors occur in while developing, so we can reduce all these all errors, and we can say faults, by doing simple simulations, and then we do actual implementation of our idea of the embedded system. So that's why what I meant, that why the simulation is necessary. So there are many web applications available for simulating your embedded system or IoT project if you are doing. So the most that the simulator I have used for the embedded system project is the link I have shown on the screen, that is Tinkercad I have used. So this Tinkercad is mostly used for designing purpose, for simulation purpose, and we will see the use of it after finishing my these slides, and I will actually show you the demo, how to design the simple circuit using this simulator or web application Tinkercad. Okay, so basically actual implementation of system includes some sensors and some boards that are used to combine all these sensors we are, or the hardware we are using for our embedded system. So as you can see in the picture given, so in the left side, we can see the all the sensors, or we can use the sensors like LED, then the motion detection sensor, then we can see ultrasonic sensor, then the motors, and all these are nothing but our hardware we are going to require. And these, on the right hand side, is the image of the boards through which we can connect all this hardware, and also we can say embed the software into these boards, so that both the hardware and software run on a single platform. So these are the boards we can use. So the most famous are the Arduino and Raspberry Pi board we can use. So basically we can do lots of software connection with it. So we can either use different platforms, or as Arduino, it has its own IDE, so we can do the programming on that IDE, which is actually Arduino language they are using, which is similar to the C programming. So if you are, even though you are not familiar with the programming side, then also you can go with this embedded system implementation. So how we are going to do this, it's I'm going to all do in this video. So let's start then. So let's start with the basic circuit. So when you are going to start with the embedded system implementation, or we are looking for the domain under embedded system, IoT, and all that, so I will basically tell you that get familiar with the basic circuit, basic electronic circuits. Why? Because it is the basic if you are developing an embedded system. At least you should know what are the current, or uh, we can say conventional current, electronic current, then how the circuits are formed, then positive terminal, negative terminal, then cathode, anode, all these basics just you need. And if you are on the engineering field, you're already familiar with it, as you are already introduced at your first sem or first year about all these basic electronic components. So if you're familiar with it's well, if you're not, just Google it up or just search on your browser. And you will just in one day you will get familiar with this all basic circuit. Just basic. For let's say register, so register, which register to use, then if you're using some hardware, so that hardware configuration and all that. So if your idea is fixed that you want to make this embedded system for this purpose, then you can just search for the hardware which you are requiring, just do some research regarding that application or the embedded system which you are going, that either it is already existing, or if it is existing, what we can add more features, so that you can put your this embedded system which we have implemented as a patentable. So this all patentable, then the prototype and all this comes under the research factor. But it's the trending that if you have made some we can say innovative embedded system which can help the social, cultural as well as the natural phenomenon of our society, then what are you waiting for? Actually, I'm going to say that it's literally your idea can help the humankind many more. Yeah, okay, so this was all that I have to tell. So these are the basic circuit we can see to light up a bulb. So the basic hardware that we require is a bulb, then a switch and a battery. So this hardware, and these are all the links, or we can call them as wires. Okay, so as I have talked about the conventional current and the electron current. So basically conventional current is the flow from positive terminal to negative, and electronic current is from negative to positive. You can Google it and you can look many more about it. Okay, so you can say the current can flow from positive to negative or negative to positive. So it is if electron current, then it is negative to positive. Conventional, it is positive to negative. Okay, so let's move further. So basically we are going to see first, that is nothing but the simulation. So I have already told what is the importance of the simulation, and I as well like to go first with the simulation and then start with my actual implementation. That actually reduces my hardware cost, and if it reduces my hardware cost, it is actually reduces the product cost estimation, right? And that is all the industries require, and you can easily implement your embedded system very fast. So let's get started with the simulation. So the first we are going to simulate the simple LED circuit, and for that I am using the Tinkercad Web Application for the simulation. And what we require for the simple LED circuit is the LED, battery and the resistor. Okay, so as you can see, these are the LEDs over here. So actually when your simulation is done, the actually hardware that you are going to purchase is as shown on the screen. So these are the LEDs. Okay, so LEDs come in various colors. Okay, so that is red, blue, green, yellow and white. Okay, then battery, so I have just put here the cartoon battery, but the battery can come on different voltages, 9 volt, 5 volt. And if you are using platform like Arduino board, then there is no need of battery unless you are going with embedded system for large devices. Okay, so this all battery comes in various voltages. Then these are the resistors. So as you can see, this is the resistor, and you can see they are the resistors are having colorful bands on them. So each band has a particular meaning. So I will not discuss about that here. You can just Google it up, and because if I go on discussing, then I will enter into the electronic platform that I don't want to enter. I'm just here to just tell you about the simulation and start to the implementation of some you can say embedded systems. So today's motto is just to do the simulation. You can actually do the simulation and actually implement your own embedded circuit or embedded systems. Okay, so these are the basic components that we are going to require for designing a simple LED circuit. Okay, so let's move further. I will just show you or just introduced you the Tinkercad Web Application, where we are going to simulate our first circuit, LED circuit. So yeah, so this is the web application of Tinkercad home. This is the home page, we can say. So this is the home page. Then as you can see, it provides the designing platform for anything that if you want to make some cartoon, make some animation, or embedded simulation. So just it provides it to you. So first of all, what we need is to sign in. If you are new, you have to join now. So I already have my account, so I will just sign in. Then I will sign in with the Google. You can do any of the login you want. Yeah, okay. So page is loaded. Yeah, right. So this is the, we can say, dashboard of your account that is open. So as you can see here, there you can set up the lessons. You have 4 blocks, you have circuits, you have 3D designs. So actually I want to do the simulation of my embedded system. So I will go and click here at the left side on the circuits. Okay, so they have given some of the circuits. I have uh, done some simulation on some embedded system, so they show your previous work here. So now let's begin. So to create the new circuit, I will click on the create new circuit. Okay, so this is the screen you get for your circuit designing. So I will just introduce you the whole screen. So as you can see, these are all the hardware which we require for the embedded system. So basically Tinkercad provides all the basic components that you can use for the simulation of your embedded system. It just includes the basic components. If you are going for the higher components, it is not available still here, but as a starter, or you are just entering into the embedded system, it is just the perfect platform for the simulation. So here we get all the hardware that we want. We can search here the hardware which we require, and we can click here for the basic or all the components. Okay, next, uh, here as you can see on the left side, you can just change the simulation name. So we are going to first to look upon the LED circuit. So I will just write here LED, light emitting diode. That means uh, circuit. Okay, so just I have given the name LED circuit to my this simulation. Okay, so we can change the name anytime you want. Okay, so this is what, so I will just, and I have already discussed that we are going to require the components for our basic LED circuit, our LED, battery and resistor. So just I will go here, I will search. You can already see the resistor here, but I'm just showing you how to search. So I will just search here like LED. So okay, so this is LED also comes in various versions or various types. So I just need a basic LED, so I will just click on the first image I am seeing, that is LED. Okay, just click on it and it will just come with your cursor, and just click wherever you want to paste it. So I just want to keep it here, so I will paste it. Okay, so whenever I just select the, okay fine, I will show you. So I am just deselecting the component, then again I am just selecting the component. So as you can see, here is the message popping up. So you can just give your LED a name. I will just keep it as 1, and also I can change as I've already told that LEDs come in various colors, right? So you can choose here the color you like, orange, and as you can see here the color is changing, then blue, then red, and so I would just like to keep it as red, and just very much well going with the red color. I'll keep it as red. Okay, so this is how you can do it. Then we have selected the LED. The next component I require is the resistor. Okay, I will show you why resistor is necessary. Okay, so I will not take the component resistor right now. So what next I require is the battery. So I'm checking the battery. So you can see there are various voltage batteries available here. So it's 9-volt battery, 1.5 volt battery, and 3-volt battery. Okay, so I will be using, you can use 3-volt battery or 9-volt battery, it depends upon you. So I will be using 9-volt battery over here. So I just selected it and just the best route I will just tab it. Okay, so it's here. Again I have selected the battery component, so it is just showing me as I cannot change the voltage over there, right? Okay, so I will just change your name, or you can change the name, and I'm again not going to change name. I don't like much going to the wastage of time, right? Okay, then I have selected okay, so you can see here the message popping up. You can change the setting over there. Okay, so I will just show you. So if that is I will just zoom it. You can see it. Okay, so this is the LED. I'm again telling you that you have to be familiar with the basic circuit, the basic hardware you are using for your embedded system or the circuit you are designing. Okay, so this is the LED, and this is, if you go on the terminals of that LED, it will show that this is cathode and this is the anode. Okay, so basically cathode is negative and anode is positive. And here, as you can see on the battery, so your battery, so this is the negative terminal and this is the positive terminal. So of course, if you want to connect this anode to the battery, you need to click on this. Okay, so as you can see, I have clicked on the red, you can say, symbol which is visible on the LED, and it is displaying that it's anode. So anode is positive, so I will just click on it and I will join it with the positive terminal of the battery. Okay, done. This is what we are doing, the wiring of the LED with the battery. Okay, then I will go with the cathode and I will join it with the negative terminal of the battery. Okay, so we can say this is also a circuit, it completes our circuit. Okay, so I have already told you that why resistor is necessary. We are going to see that. So to run this circuit, what we have to do, or any circuit we have designed or embedded system we have simulated, so you go up here and you can see here the start simulation button, right? So I will just click on it. Okay, it will start the simulation and you can see the LED bulb has gone. Okay, now you can see here it is showing the we can say icon like bursting up, or it's just short. If you had implemented the circuit in actual, that without simulating or without designing, so your LED might have got destroyed till now or have got short till now, and you have wasted one LED of in your hardware components. So that is, you have wasted the LED cost which you have given for purchasing this LED. So this is how the simulation or simulator is very useful. So as I can, when I simulated and I have run the simulation, I have seen that this 9 volt is very high for this small LED. As you can go here and they show you the message that current through the LED is 915 milliampere, while the maximum current the LED can hold is 20 milliampere. So you can see the huge difference between the currents flowing through the LED. So this is why the simulation is very much important before you are going for the actual implementation of your embedded system or the circuit. Okay, so what we need here to do is we need here to put the resistor between the battery and the LED to reduce the, we can say, the current flowing through the circuit. Okay, so once again I will say this is why the simulator is important. So till now, if you have directly gone and just to, if you have been, or we can say you had just implemented this in actual, in real, so your LED has get short, you have wasted money on that LED, and you need now to again combine the resistor and again go with the new LED and complete a circuit. So that's just waste of money. So this simulator is just useful that you can simulate here and then go for the actual implementation. So let's stop the simulation. Without stopping, you cannot, as you can see, I cannot move this component, I cannot move the wire. Okay, so why? Because I have not stopped the simulation, I cannot take the new component over here, cannot delete anything, nothing. Okay, so I just need to stop the simulation. Again I will go here and I will stop the simulation and again do the changes in my circuit. Okay, so I have already told you the conventional current and the we can say electronic current. Okay, so you can do any of this. I will be doing is conventional current, that is positive to negative current flow. So now I am going to search for a main component, that is resistor, right? So here is the resistor I got and I am selecting it and I am placing over here. Okay, so if I go here, I can see the properties of the resistor, I can change the name and also I can change the resistance. So let's go and just I'm selecting this wire and I'm moving it from here to the terminal of the resistor, and again I am selecting the terminal 1 and then I am joining it to the positive terminal. Okay, so the current will be flowing from here, then here to the negative. So basically when you are actually doing or using a board, so this black we can say is as a ground and red color is mostly for the voltage or the current. Okay, so if you click on the wires, okay, so you can change the color of them as well. So if negative terminal I will be using black color, and for the voltage or the current, positive current, positive terminal I will be using red. Where it is red? Oh, red color. Okay, I'm just using here red. Okay, so it just simplifies your circuit, nothing else. You can keep the wire it is, but for understandability it's much more easier. Okay, so then then we will start with the simulation again. Okay, so as you can see the LEDs has blinked. Okay, the LED has on. Okay, so that means that the circuit is completely all right, the current flowing through the LED is all okay. It is uh, between till 20 milliampere. Okay, why? Because we have added the resistor which is controlling the flow of current to the circuit, and it is providing the current which is required for the LED. Okay, so if we click on the resistor, it is showing that the resistance here is 1 kilo ohm. Okay, so it is best we don't need to change the resistance, and it is performing well and LED is going perfectly. It's not showing any warning. That means the current flowing is below 20 milliampere. Okay, so this is the simulation of the basic LED circuit. Hope you liked our first simulation video of LED circuit. So in the next video we are going to see the next circuit. Okay, so stay tuned, and I hope that you like the today's video. Don't like to subscribe, then like the channel and comment in the below section and subscribe to our channel. Thanks for visiting the channel, and hope you like the video. We will be coming with more circuits, we will be coming with more embedded systems, connecting all the hardware with the wireless, that is internet, and so on. I don't just want to be going don't want to make a complex can say complex learning. So we will just do the micro learning process, that we will be uploading short videos of these embedded systems, right? We will be um, one by one moving towards the IoT part. Okay, so I hope you all will be going through this simulator, web simulator, Tinkercad. Okay, there are many such simulators, web simulators available on the net. You can just Google it up, search in your browser, you can get it. But I feel very much easy working with the Tinkercad, so I'm using it. Okay, so I hope you like the video, today's video, and just keep subscribing for the next videos we are going to upload. So thanks for watching. Okay, so I will stop the simulation, and I hope you like the video. So thank you for watching. See you soon. Bye. Okay, fine. Just wait. Um, if you have any doubt related all this, you can just comment below on the YouTube video. Okay. So I will just try to answer as many questions or queries as possible. Okay. So thanks for watching.